Hello everyone. In previous video, we see that a hardware interface with the Blockzie software. In this video, we will see the Arduino programming real time in the Blockzie. In this video, we will see what is a real time, what is a programming in real time, and see some basic activities. What is a real time? So basically, there are two modes of Arduino Uno in a Blockzie software. One is a real time and another is a upload time. In real time, in this mode, you can write scripts for the sprites and boards like Arduino Uno, Nano, Mega to interact with the sprites in a real time. In case if you disconnect the board in a Blockzie, you cannot interface anymore. Also, in this mode, you can control Arduino pins by assigning a sprite's movement, such as when space key of keyboard is pressed, then LED gets turned on and etc. Let's move to the upload mode. In this mode, allow you to write scripts and upload it to the board that you have selected so that you can use the board even when it is not connected to your computer. We can display data on serial monitor using this mode. In this mode, only one event block is present. Here, we can see that the real-time mode, and when you click here, where my mouse is seeing, you will find a upload mode also. Programming in real-time mode. So here are some basic steps while we use programming steps in a real time. So connect the Arduino Uno to the computer or laptop via USB-A to B type cable. Then once you plug in Arduino board, a LED will start blinking which indicate your Arduino board connected to PC. Open your Blockzie software, then click on No Devices Selected from the toolbar. Click on the Arduino Uno. Click on to connect the port. Click on Go to Editor. Then in the block palettes, you will see pin blocks are displayed. In the real time, you have to work only on pins block for the Arduino Uno. Now observe the block palettes. Here you can see that, and you find something new. Yes, in the block palettes you will see block are displayed like pins, the pins block and etc. Let's see here activity number 1, which is a controller pin number 13, which is already by default assigned to an inbuilt LED in our Arduino Uno microcontroller board. So for this experiment, we need a free hardware, Arduino Uno microcontroller board, USB-A to B type cable, and obviously a computer. So here it is a circuit. Here you can see this is our Arduino board, and the LED circuit LED is connected to a ground and pin number 30, which is a anode and cathode. Let's see a code of activity number 1. Here we can see that first of all we set the pin number 13, which is a digital pin, as we previously seen in our previous chapter. LED is connected to a digital pin number 13. So first of all, we will set the pin number 13 to a mode of output, because LED is a output device for our microcontroller. Then we will take a forever loop, because we need to LED blink. It means we need to turn on a LED and then hold for a certain time and then turn off the LED as per our requirement time. So here we take a forever loop, and in this loop we will write a code like a set digital pin 13 output is high and wait for a 1 second. We can manage this second as per our requirement at how much time we need to delay the high and low time of a LED, or in between a blink we need a time. That time we can decide it as per our requirement. Then we will put here a wait 1 second block. Then we need to turn off the LED, so it seems like a LED is a blinking. We will use set digital pin 13, output is low, and again we put the block of a delay, which is a wait 1 second. Let's take a activity number 2, which is a interfacing of a IR sensor. So here we need some hardware like a Arduino Uno, USB type A to B cable, a laptop or a computer, a IR sensor, a jumper wire, LEDs, and some 220 ohm resistors. Here are the circuit for activity number 2. Here we can see that the pin number 13 of a Arduino Uno microcontroller board is connected to a LED through a 220 ohm resistor, because the LED or operating voltage of a LED is different as a with compared to a microcontroller's output voltage, which are the 5 voltage. An LED need a lower voltage to turn on and off. So here we use a 220 ohm resistor. And another side, we take a IR sensor. The full form of the IR sensor is an infrared sensor, which is used to fire an infrared frequency and to detect something dark and light color. Here we can see that the VCC and the ground is connected to the 5 voltage and a ground of a microcontroller board, and the signal is D0 pin, which is connected to a pin number 2, which is also a digital pin. Let's see the code of the circuit. So here are the coding steps. First, let's change the backdrop. Click on the choose a backdrop button and choose the blue sky backdrop from a library. Now select the penguin from the sprite palettes to create his grid. You will notice that the penguin is standing in the center of the stage, and we want him to be near the bottom edge. For doing so, change his y coordinate to -110 or 110 in the sprite palette. Now go to the motion palette, drag and drop the glide second to X and Y blocks, set the gliding time as a 0.5 second and X and Y as a 110 with these Toby glides in the upward direction. Then we will see here that we can move our penguin sprite as per our requirement, and we will operate our sprites by using the Arduino microcontroller interface and using which is a IR sensor. Here we can see that first of all we will set the pin number 2, which is a IR sensor pin, as an input, because we will take the signal of IR signal as a input on a digital pin number 2, and then we will set our 13 number pin, which is the output pin of the LED. Here again we will take a forever loop, because we need certain commands to be run continuously. Here we will take a condition. So we take a if else loop. Here we give a condition. If the digital pin 2 is high, it means when the IR sensor is detect something, then set digital pin 13 output to the high and say object is detected. It means when our IR sensor detects something in front of it, then the LED will glow, and in our screen the message will be appear, which is a object detected. Otherwise, otherwise, it means when the second condition is execute, it means when the IR sensor is not detected something, then a digital pin will be on a low state and say the object is not detected. Thank you.